Okay, so let's see. We have unit vector. Okay. So as the name suggests, unit vector means a vector which has magnitude 1. A vector whose magnitude is 1 or magnitude is unity. So a vector which has its magnitude as unity which is magnitude 1 but direction is that of the original direction. Direction is that of the original direction. So for this we call the unit vector as, let's write the unit vector. So suppose we have a vector, let's say I represent this vector. Okay. So this is a vector A, and when this is a vector A, if I want to write on unit vector, so unit vector A, unit vector will be represented by this. It will be only if the magnitude of the unit vector is equal to 1. Then we will call this vector A as unit vector. So if magnitude of vector A is equal to 1, then we call this vector as unit vector. So for simplicity, we define unit vectors along x-axis, y-axis, and z-axis. So here we take, let's take here, let this be your x-axis, y, and z-axis. So now we define unit vectors along the x-axis, y-axis, and the z-axis. Unit vector along the x-axis, unit vector along x-axis is represented by the symbol I cap. Unit vector along x-axis is represented by I cap. I and a cap over here. Similarly, if A is a vector and I want to denote the unit vector of A, so unit vector of A is represented like A cap. So if you write A cap, it means unit vector A. Okay. So unit vector along the x-axis is denoted as I cap. Unit vector along the y-axis will be J cap, and unit vector along the z-axis will be called as K cap. So these are the annotations. How we see? We see unit vector along the x-axis. That means a vector of magnitude 1, but direction along the x-axis will be represented as I cap. A vector along the y-axis, but magnitude 1 will be j cap. A vector along the z-axis, but magnitude 1 will be called as k cap. It will be denoted as k cap. Any unit vector, suppose I want to represent the unit vector a cap, the unit vector a cap will be given by vector a, the vector a divided by its magnitude. If you divide any vector by its magnitude, you will get its unit vector.
Sir, those two lines are called as modulus, right, sir?
Yeah, they represent modulus or magnitudes.
Okay, sir. Okay.
They are modulus or magnitudes of the vectors. So here, uh, suppose if you have 20 Newton force acting towards north. So if you divide that 20 Newton force by 20, you will get 1 Newton force and acting along the north. So in this way, you can obtain unit vector of any vector by dividing the vector by its magnitude.
Yes.
If you divide a vector by its magnitude, you will get the unit vector of the corresponding vector. So from this, we have another thing we can write like this. We can write vector A as the unit vector a cap multiplied by the vector A, multiplied by the magnitude of the vector. So these are two important notations. To find out the unit vector, you have to write vector A divided by its magnitude. And if you have, suppose here, a unit vector, so if you multiply the unit vector by the magnitude, it will give you the original vector. Also here we have written the unit vectors along the x-axis, y-axis and z-axis. They are represented as I cap, j cap and k cap. So here you have along the x-axis, you have a unit vector. Along the x-axis, you have a unit vector I cap. Along the y-axis, you have a unit vector j cap. And along the z-axis, you have a unit vector k cap. So in this way, we will try to represent any vector in terms of I cap, j cap and k cap. So let us see, let us try to represent a position vector in terms of I cap, j cap and k cap. So suppose you have a position vector of a point P. So from here, you have a point P. Let this be the point P. Let us suppose it has the coordinates x, x1, y1 and z1 are the coordinates of this point P. So OP, the vector OP will be written as x1 I cap plus y1 j cap plus z1 k cap. So this is how we represent vectors. Any
Yes.
vector in the xyz plane, xyz coordinate will be represented by x1 I cap plus y1 j cap plus z1 k cap, where x1, y1 and z1, they are the coordinates of that point. Okay. So let us try to perform a few things with each, whatever we have understood. With these topics, we will try to perform a few operations. We will try to see a few questions based on these. So let us say you have a vector. Okay. Find the magnitude of following vectors. So I'm giving you some vectors. We need to find its magnitude. Hence, find their unit vectors. So you also need to find their unit vector. Okay. So let us see. Uh, you have a vector given by 2 I cap.
So unit vectors will always be one, right, sir, of that unit.
The magnitude of the unit vector will always be 1. But
Okay, sir.
what should be the direction?
Yes.
The direction would be somewhere different. So here you have 2 I cap minus j cap. This is the first one. The second one I give you have 2 I cap plus j cap plus k cap. Then third I'm giving minus I cap plus j cap minus k cap. So these are the three vectors. I want to find out their magnitudes. So let this vector be equal to vector A. Let this be equal to vector B. And let this be equal to vector C. Okay. So as we know that a vector is represented here, the vector A is represented as 2 I cap minus j cap. Now since this vector, the magnitude of the vector is equal to the length of the line, right? The magnitude of vector A is equal to the length of line from the origin. Since this is from the origin, so whatever will be the length of this vector, that will be its magnitude. Okay. So can we find out the distance of this vector? Can we find out its length? Its length would be given by the distance formula. As we know the distance formula, so we can use the distance formula from the origin to find out the length of this vector. Okay. So the magnitude of vector A will be given by under root of x1 square plus y y1 square plus z1 square. This is how you take the magnitude of the vector. So the magnitude of vector A will be equal to under root of 2 squared plus minus 1 squared, and hence we'll get this answer as under root 5.
So,
So
sir,
this
the coefficients are basically the vector, sir.
coordinates, the coefficients are
Oh yeah,
basically the
sorry, yeah, the
coordinates.
coordinates, sir. Yes, sir.
Okay, here we represented the vector like this. See, x1 I cap plus y1 j cap plus
Yes, sir.
z1 k cap. Remember? So x1, y1 and z1, they were the coordinates of point P. And
Yes,
I'm
sir. Yes, sir.
writing the vector x1 I cap plus y1 j cap plus z1 k cap. So that's what written here. We have 2 I cap minus j cap equal to vector A. So 2 is the x coordinate, minus 1 is the y coordinate. Okay. And z coordinate is not given, so we'll take the z coordinate as 0. So hence we get our magnitude of vector A as under root 5. Can you find the unit vector? If I am to find the unit vector, so unit vector would be given by A cap. So A cap is the unit vector, and it will be given by the vector A divided by its magnitude,
Yes.
right? So the vector A is 2 I cap minus j cap. This is the vector A, and divided by under root 5. So this is our unit vector. This becomes our unit vector. If you find out the magnitude of this vector, let this be 2 over under root 5 and plus minus, this is I cap minus j cap over under root 5. So if you find out the magnitude of this vector, the magnitude of this vector will be 1. You can try and find out the magnitude of this vector will be 1. Got it?
Sir,
Try.
I'm not understanding the concept behind this, sir. Like, why 2 I cap minus j cap?
Okay. 2 I cap minus j cap is the unit vector, is the vector A.
Yes, sir.
Okay, and we have defined the unit vector by the formula. We know the unit vector of any vector will be given by unit vector or A cap will be given by vector A divided by its magnitude.
Yes.
Okay, so here you have the unit vector I want to find out. Vector A is given to me, which is 2 I cap minus j cap. So here I write 2 I cap minus j cap, and the magnitude of the vector A I have determined to be under root 5. So if I divide this vector by under root 5, then I get unit vector.
Okay, sir. Yes.
So you can check out if you can consider it as a new vector, and if you find out its magnitude, you will get its magnitude to be equal to 1. You can check, you can find the way you found out the magnitude of vector A. If you try to find out the magnitude of this unit vector A cap, you will get it 1 on. Okay, like you will make 2 over under root 5 whole square plus minus 1 over under root 5 whole square, and then you will get the answer as well. Okay. Now, find out for the second one. Can you do just one? Then Shesi, try to do the second one.
Sir, we get 2 I cap plus J cap plus K cap whole divided by under root 6.
Okay, first tell me what is the magnitude that you get.
Under root 6.
Okay, we get the magnitude as under root 6. That's 4 plus 1 under root 6. Okay. And unit vector would be 2 I cap plus j cap plus k cap minus or divide by under root 6, right?
Yes.
Okay. Find out for the third one also. Find out third one, then I'll give you some more questions.
Sir, it'll be the entire vector C divided by uh,
Magnitude.
under root
What?
3.
Yeah, vector c divided by its under root 3. Okay, everyone is getting just one. Dhanunjay,
Uh, yes, sir.
Jaswant and Dhanunjay, are you solving out?
Yes, yes,
Solve
sir.
it out.
I'm trying.
Please take your pen and paper with you. Solve it out. Okay. Solve it, then you will get. Okay, let's try to do the same question in a different way. And now let's see. See here. An object moves from -7, comma 2, comma 4 to 7, comma -2, comma 4. Okay. So you have to find the original and final position vector. Okay. Also find displacement vector. Hence, find magnitude find magnitude of displacement. Okay. So just one, can you tell the original position vector?
Yes.
Just one, what would be the original position vector? Okay. So see what
Sir,
are, yes.
sir, I'm not understanding what is original and final vector, sir.
Okay. See the original position. The original position is P1, which is given as -7, comma 2, comma 4. This is the original position,
Yes, sir.
and position vector is taken up from the origin. Okay, so position vector is taken from the origin. That means you want to find out the position vector OP1, and this would be given by the this position minus 0. Hence, you can write down as -7 I cap plus 2 J cap plus 4 K cap. This is so simple. You add unit
Okay.
vectors. You just add
Understood.
unit vectors to the coordinates, corresponding coordinates.
Then final vector, sir. What do you mean by that?
Yeah. So final vector is its final position. Final position, let this be P1, let this be P2. So final position is at P2, right? So final
It is
position,
from origin to P2.
yeah, origin to P2. That is
Okay, sir.
OP2. This should be the final position, and it should be equal to 7, comma -2. Sorry, 7 I cap. It has to be equal to 7 I cap minus 2 J cap plus 4 K cap.
Understood, sir.
So whenever your coordinates are given and you want to find out the vector, okay, so you will be for the position vector you can take them directly. And now to find out the displacement, how can we find out the displacement? See, to find out the displacement vector, do not panic even if you are not getting, okay. Just try to understand. I will give you more and more of examples to understand. Okay, we'll take here more and more of examples. Until now, we are not into the complete depth of the syllabus. When we enter into the complete depth, everything will be clear. Okay, so here
Yes.
we know the displacement. The displacement we can find out by two ways. We know the displacement is given as final position minus initial position.
Yes.
So we can take here final position minus initial position. So I will explain this to you both. So your final position is 7 I cap minus 2 j cap plus 4 k cap. Initial position is this one. So can you find out the displacement vector?
8k
Right.
cap.
Yes. How much?
It will be 8k cap, sir, because rest of them will get cancelled when you.
No. Put
Oh wait,
at the
it's
place of
subtraction,
final
sir. Okay.
position, write down here 7 I cap minus 2 j cap plus 4 k cap minus your initial, which is minus 7 I cap plus 2 j cap plus 4 k cap.
Yes, sir. Yes, sir.
So 7 I cap minus 2 j cap plus 4 k cap, 7 I cap minus 2 j cap minus 4 k cap. So we have our displacement as 7 plus 7, 14 I cap
Minus 4 I j cap.
minus 4 j cap plus 0 k cap.
Yes, sir.
So this is
We
the
have to write
displacement.
0 k cap, sir. We don't have to.
Yeah, you need not write. Even
Okay.
if you write, there is no problem. If you don't write, no problem. Okay. So this is the displacement. Now, can you find out the magnitude of displacement? Just once. Can you tell the magnitude? Just here we discussed how to find the magnitude of a vector. See, here we discussed how to find the magnitude of vector. So displacement vector we have, and we want to find out its magnitude. So its magnitude will be given by under root of 14 square plus 4 square.
It will be divided by under root 212.
Just magnitude I want. So magnitude will be 196 plus 16.
Yeah, exactly, sir. Under root 212.
This will be under root of 212. This is the displacement. This is the magnitude of displacement. Now let's try to understand this complete scene with the help of the coordinates. What it actually means. Okay. Now I will show you the complete scene. Whatever we have done here, I will show you complete thing over here. What actually we have done.
Excuse me, sir.
Yes.
Sir, actually, I have to leave for somewhere, sir. So I have to leave the meeting, sir.
Okay. 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 Sure.
Yeah. Thank you, sir.
So you have the x-axis, y and z. Let us say you have this point P1 and you have this point P2 as the final position. So the original position vector will be given by OP1. Then final position vector will be given by OP2. Just one.
Yes, sir, we are listening.
Okay. And
Yes,
the
yes.
displacement vector will be given from P1 to P2 is the displacement vector. Let this be the vector OP1 This be OP2, and this is your displacement vector. Since it has displaced from P1 to P2, so this is the displacement vector. It's quite simple. Can I use the triangle law of vector addition here? Do I have three vectors?
Yes, sir.
Yes, sir.
So which two vectors can be added to give the third vector?
OP vector.
Which two vectors
OP2.
are in order?
Yes, sir.
See, OP1 and displacement vector, they are in order, whereas OP2 is in opposite order. So if I use the triangle law of vector addition here, I observe that OP1 vector plus the displacement vector will be equal to the OP2 vector. Okay. So the displacement vector S would be given by OP2 minus OP1. So this is what we have utilized here. Before here we utilized this one only to find the displacement vector. See, the displacement is given as final position vector minus the initial position vector. Haven't we done the same thing? Yes.
Yes.
We have utilized the same concept and hence the displacement vector is obtained. Now to find the displacement, magnitude of this displacement, we need to find out the length of this line P1, P2. Okay. And the length of this line P1, P2, either you find out vectorially, we have done, or the other way was, you are given the coordinates here, x1, y1, z1. Here you are given the coordinates x2, y2, z2. Okay. So if I use just the distance formula, I will get the length of this line. And using the distance formula, I can get P1, P2 as the displacement, which will be equal to under root of x1 minus x2, which is 14 squared plus 4 squared plus 0. So this would be again the same thing, under root of 212. Yes, any doubts here?
No, sir.
So see, at least for today's class, you should be aware or you should know that how we are obtaining, converting from coordinates. We can convert from coordinates into the vector form. We can convert from vector form to the coordinates. Okay. Okay. So bye all of you. See you again in the next class. Any doubts?